Hello again, this is Travis, and this is another video on my math paper. Um, Basically, it's changed. Last time I looked at it, it was about Riemann sums and his hypothesis and such as. And actually, since then, it's been a while where I changed it to looking at, well, derivatives in applied computer science. And this is a look at some of the code. And this was just a test to try and trick uh, the compiler into treating the variable x as a variable and not as a value. Now this is called test.java. This isn't really it. I'm going to show you the design in Eclipse, and it's going to do that, and voila. Now here I have I think I have some code that acts as a action, yeah, button output, button input here. As you can see, there's action performed. Basically, what I did was I tried to make X. So say you run it, and let's see, you go run as okay. Let's run test. You click input here. You put in, let's say, X. Okay, and then the idea is that when you click derive, you get 1 because derivative of X is 1. Now, what this means is that the derive button is not working correctly. The input is, but the derive isn't. And what I figured out was that, well, if that's the case, maybe what I need to look at is something that allows me to make the x, instead of making it a value, treat it as a variable. So, what I did was, if dx equals x, then it should output this message dialog where it says your input, and then it says the derivative of your input is just 1. Now this is very, very basic, and it takes what you put in only if it's x. Now that becomes an issue because you're assuming for only the case of x. But what if you put in something greater? Okay, say you put in x squared, right? So x squared would be like this, x raised to the 2, caret 2, and then when you click the derive, the idea is that it would output to the user 2x because you bring down the 2 as the coefficient, you subtract 1 from the power, and that's called the power rule. And the power rule, I have a window for that right here. And that window, well, it's not working entirely. And this is what it looks like in the raw format. When I run this, it looks just the same, right? The output looks a little funky there. You get your exponent, so it, say you're raising it to the 2, and your base is just x. Well then, when you get derive, if you put in x and squared, you should get either in this box or just output another pop-up window like in J option pane. Take that when you click derive and say, hey, x squared, the derivative is 2x, or 2x to the 1. And that's not working entirely. So to get around the math, what I did was I created another file in Python, and this is the shell right here. And just to make it a little bit easier, okay, where is it? Okay, I did the math, import math as math, right? Okay, and that worked fine. So from here, what I did was I created a function, and I called it power rule, and I said base and exponent. And it's taking a little while. There you go. Okay, and in Python, the syntax is a lot simpler. It's a lot closer to English. So I'm saying the name of the function is power rule. My base is b. Exponent is this. So now what I'm going to do is I'm going to make it a little bit smaller named variables within the function, not global. So b equals base. Comma means that I can make another line of code within the function. So I say exp equals exponent. And from here, what I do is I take exp equals exp minus 1, because I can't remember how to make it shorter. I'm not sure in Python if you can do exp minus minus like you can do in Java and I believe C++. So what I do is I take that. Let's actually, before I forget, power rule, right? So according to power rule in derivatives and differentiation, the idea is that you take the exponent and you take it and multiply it by the base. So in order to do that, I'm going to make b equals base times my exponent, right? Oh wait, there's an 8 and then it's not supposed to be there. Okay, times exp. Okay, so now what I've done is I've made my b what I made earlier base. So say my base is x. I'd say, okay, well base, if base is going to be x, so say x is equal to 2. Okay, well 2, it's saying my exponent is 3, so 2 to the third is 8, right? So if that's the case, so b equals 2, exponent equals 3, exp equals 3 now as well. So I'm saying, okay, b equals, I put in 2 and 3, so 2 times 3, and that's 6, which is true. When you're deriving, that's the case. You multiply them. You don't actually raise it yet. So when you further apply this rule, you get exp minus, or yeah, exp equals exp minus 1, because you have to subtract it once you've multiplied it. And then return b comma exp. Now sometimes this works, sometimes it doesn't. It's proved to be a little temperamental. Now say you call it, okay, with power rule, and you say, okay, I want 2 and 3. Okay, it doesn't like that. It doesn't like the tuple and int for some weird reason. So exp equals exp minus 1. Let's go back, and I have to actually go back directly into the function and create again, unfortunately. Now if you notice, I have to go back into it again. I have to make the whole thing all over again. In Java, that's nice and I don't have to do that. And in Java, an even better part is polymorphism. If you're unfamiliar with that, that's basically saying I can create a different name, and let me just show you my Word document. It's not there. Let's make it a little easier for you guys. And it should be looking a lot like a function name, and function name, where you take it and, okay, that's my little paper there. I'm going to scroll down here for you. And I'm going to show you what I'm talking about, because polymorphism, it's a really big deal when it comes to making code sometimes, and it makes it a lot easier. So this is what it is. It's essentially, it's a very simplified version right here, but it works so that a function name can take different parameters. This would look something like this in pseudocode. Now, this way, it can go to any programming language you choose. In this case, I'm jumping back and forth between Java and Python, and that's perfectly fine. Okay. So I think I'm back at where I was a moment ago. I'm not entirely sure. And what I wanted to really explain here is that polymorphism would allow me to go into the Python code, create power rule 3 different times, or 2 different times, and assume a base only and a base and an exponent only. So that way, if I go to find power rule, I can just go like, oh, okay, well, I want a different parameter set. Say I only need a base, right? Well, if I don't have an exponent parameter, what does that mean? Well, typically when you're differentiating or deriving functions, you're taking what your base is. You're saying, okay, well, b equals base for shorter and faster typing. And then you say, okay, well, I need to multiply my base. Well, if your base equals x, okay, base equals x, you need to make sure that, oh, well, then I just need to print to the user 1. I need to print f of, well, hold on. Okay, f prime of x. What the heck? Okay, prime of x. Oh, and this is where it becomes tricky. In Python, there's a nice little thing to it where you can do double quotes and single quotes in different arrangements. But to keep it simple, what I'm going to do is I'm going to do f prime of x, like that, equals 1. Because when you derive just straight x by itself, when you just derive x, you always get 1. It's a known fact when you're differentiating like that. So I'm going to close that, and then I'm done. Because, well, actually, no, I'm not. I need to go else. If it doesn't equal x, then it equals, if it has x or has a caret, that means I need to assume the other power rule, which contains an exponent, right? Well, I can't do that in here. I can't do that because polymorphism doesn't exist in Python, or I just haven't figured out how. In this case, what I have to do is I have to create another if statement. I can't even do an else because that's checking for anything else. That's not that. So specifically, I have to go back and say, hey, if this, and I just realized I don't need base check x. I need to say b equals that. Wait, a little shorter. And in case you didn't know this, before I forget, in Python, a nice little keyword is elif. But that's not useful in this case. I'm going to ignore it because I don't really need it. From here, I'll just go, I'll say if b is greater than or equal to x, greater than 0, sorry. If it's a number, I just get, well, actually, even if it is greater than 0, or b is less than or equal to 0, or b equals 0, because that is also possible. Oh, wait, I need to put that or there, right? Gotta keep that proper syntax going. Then I go, okay, well, now I need to check for any constants. Okay, a constant is like pi, or the square root of 1, or square root of some number. Okay, not i's. Those are imaginary numbers. They don't count. So you're looking at rational numbers. Any rational number, in this case, is what I'm checking for. And I'm saying, okay, if it's any of those numbers, any rational number, then I need to go, hey, no, that derived is just straight up, right? And that's what it equals. Any constant derived is 0. No matter what, that's always the case. If you apply power rule to any constant, think about it. You do 1 to the 1th power, or 2 to the 1st power. 2 to the 1st, well, 2 to the 1 minus 1 is the same as 2 to the 0 power. And anything to the 0 power is just 1, right? Well, in that case, it's like 0. It's a special number. And that's what happens. Okay, and now I'm done. So now if I call power rule again, okay, to start it out, it just assumes base. That just goes to show that in Python you can't do polymorphism. Or at least I can't yet. I'll find out soon if it's possible. And by doing this, I can go, okay, if it's x, I can go, bam, and it doesn't like that. Name x is not defined. Wait a minute, why is it not defined? It shouldn't be undefined. Oh, okay, notice that what I did here was I made the mistake of not putting in the single quotes around it. If I put single quotes around it, it prints out f prime of x equals 0. Wait a minute, why is it printing it that way? Okay, now if you notice here, it's going here and saying, just check against this. But for some strange reason,